Hi folks, I figured out how to save $300 by doing $1,600 worth of work. Welcome to another Wednesday. I mean, no disrespect to Mr. Saunders. The guy and his team is an inspiration. Did I save any money here? A little bit. I mean, I could have bought basically the same thing from him for about $300 or $400, which is super reasonable when you think about what you're getting and what it's capable of. Why did I do this instead of buying it? Well, part of it is I knew that if my first project didn't require that I compensate these axes and compensate for lash and square the machine really tight and get everything just perfect, I would never do it. The thing that moves the x-axis on this machine is a screw. It was formed by a process called rolling instead of grinding, and now we're grinding. Now that's really important for reasons that you don't need to understand completely, but that result in what's called pitch error along the screw. This one happens to be 16 threads per inch. That's the number of threads for every inch of screw. Accordingly, if I were to rotate this 16 times, you would expect a nut on this screw to move 1 inch. However, there are accuracy problems with the roll forming that was used to make this screw and the screw in this machine. For me to be able to trust the position of this machine to within about 1/1000th of an inch, what we need to do is mechanically tell the control system to move the machine what it thinks is 1 inch or 1/2 inch, and then measure the resulting motion, which will almost certainly not be exactly 1 inch or 1/2 inch. You repeat this in this case 1/2 inch intervals over the entire length of the machine. You put it into a table and then call your machine compensated. This is a huge pain in the ass. This is a minimum quantity lubrication system. What it does is it takes shop air and uses it to atomize a stream of whatever you put in this container. Now, the way to remove a lot of material really quick with a small diameter tool is to run really fast. You run really high speeds. The problem is your surface feet per minute on the tool, that is, as the tool is rotating, if you set this tool edge on the ground and let it take off, how fast would that be going? That's your surface footage. And as your surface footage goes up, the potential to generate heat also goes up. So your tools need to be really sharp and you need lubrication. Even with an air jet or high pressure, it's hard to get the coolant in there. So having a very, very low viscosity coolant really helps. The other advantage is this generates really small chips. And if you use a regular oil or a regular emulsion, that dries out and turns into this horrible sludge that you need to clean off of this. Alcohols, like ethanol or Everclear over here, they don't leave any residue. They evaporate away completely. Of course, I wouldn't duplicate his fixture plate if I wasn't going to buy some of his stuff, so. Alright, so this isn't sponsored or anything, but this 1/4 inch Amana Tools O-flute polished end mill is a freaking aluminum munching machine. Like, look what that one thing has been through. The cool thing about the Saunders system is with this plate, the first 1/4 inch is a precision 1/2 inch hole, and all of his stuff has pins, like these diamond pins that fit into those 1/2 inch. It's not going to fit because they're full of chips, but that fit into those 1/2 inch holes, and then the rest of it is threaded all the way down, so you get your fasteners in there too. So each hole is both locating and retention via 1/2 inch 13 fastener. Moment of truth. It's not as pretty as his, but does it fit? Oh yeah. Look at that. Not even an ounce of wiggle. So what is this thing? Is this a crash? No, this is a datum feature. You'll notice I cut this in X and Y to a known perpendicularity and a known offset from everything else on the plate and anything that might go on the plate in the future. That means that I can CAD any setup with the 3D models provided by Saunders et al. So kindly, and run CAM on that same CAD setup because I know where everything is pretty precisely. Ooh, piece of candy. Ooh, piece of candy. Their system is awesome on every machine they support, especially with their big steel plates. But John, these were made for routers. If you're listening, check out the Z travel that we get stuck with here, and this is a tall machine. You know what a Curt D40 looks like on this? It's ridiculous. And the unanodized aluminum plates are perfect for this. Cutting forces are low, clamping forces are low, and the cost per square foot also low. I'm just saying.